welcome here in our lab.
Thank you very much. Can you explain where exactly are we, Robert?
So we are in the main lab of Alcium. Alcium is a company I started now 12 years ago.
12 years, okay. Yeah.
And so you see we have some stuff, some interesting test equipment
Yeah, you can say it is, it's a, this is just one room, I believe.
So the idea was to start a company to help startups mainly to develop their electronic products with a key focus on wireless and mixed signal designs, things where electronics seems a little complicated. So
I think that is your specialities,
yes,
wireless
yes,
and
yeah.
Mixed signals, and
Yes.
etc. etc. Heard you saying we love equipment.
Yeah, we love test equipment, so that's the good news. So we have some money and we love equipment, so we can buy some things.
Good.
And in wireless in particular, it's very critical to have enough equipment to understand what's going on.
What are you using this setup for? What sort of measurements are we looking at?
So for example, we have a spectrum analyzer, so the one running it.
Yeah.
And here it's a quite nice Tektronix real-time spectrum analyzer. That allows either to see the spectrum of a signal, but also to demodulate information to understand what the information flow is between two equipments. But you have also, for example, one of the most difficult part of a RF project is the antenna, and to work on antenna you need a vectorial network analyzer. Here you have.
Okay,
a VNA.
where?
So this is a VNA, so an old one, but a nice one. From HP, maybe 30 years old, but still working.
Still working, 30 years old.
Yeah, more specific, more dedicated equipment, like a noise figure meter. This is a noise figure meter in order to measure the quality of a receiver. Also an old one, but still working.
A lot of equipment what you're using for your RF and for your wireless measurement is actually not new,
Not new, and probably our key supplier is eBay. Half of the equipment here come from eBay, just because we have not enough cash to buy this equipment as new. For example, this spectrum analyzer, we bought it new, but nearly all the other ones are from second source. For example, this is a 20 gigahertz oscilloscope. If you buy it new, probably it's 100,000 euros.
20 gigahertz.
20 gigahertz, yeah.
Okay, good.
Sampling oscilloscope. So new is a cost of fortune, and this one we bought it from 1,000 euro maybe. If you look often on eBay, and if you are, ready to take some risks, what the risk is, you can look there, and here you have a faulty RF generator behind.
Okay.
So if someone is able to come and repair this one, we will be very happy.
Okay.
So if you want a 13 gigahertz oscilloscope, this is one.
Okay. Where exactly are you using this scope for? What is the...
So the key target for such a high-speed scope is to validate, to qualify high-speed digital signals, like gigabit Ethernet, USB 3, this kind of stuff, which are, intrinsically using gigahertz as a baseband frequency. So if you want to qualify such signals, you have to have a 10 gigahertz oscilloscope or more. That's it. It was our Christmas present. We are trying to do as few software as possible.
Okay.
We are mainly hardware guys.
Yeah.
Maybe do you want to see an anechoic chamber?
Many people know you as the author of The Dark Side, but I think you're now taking us in the dark room.
Yeah, in the dark room. Light is on, so...
The light is on? Okay.
Yeah. You can come here, the sound will be different. So, welcome in the anechoic chamber.
Yeah.
So...
And this is the dream place for a lot of people who are into electronics and RF design.
Yeah. It basically allows to reproduce in indoor some very clean outdoor configuration for RF. So we can measure an antenna, we can measure radiation pattern, we can measure transmitted power. Just putting a product here, moving it around using this automated platform. And then measuring the signal received on the other end through this reception antenna.
Electronics, yeah. What exactly is the darker side of electronics?
So now the idea was to, at the beginning, 10 years ago, when I started this adventure, this writing adventure, the idea was to write articles on subjects that are perceived as difficult in electronics. So starting with electromagnetic compatibility, radio frequencies, difficult stuff like that, maybe signal processing, things like that. And so the idea was to write articles bringing this subject out of the darker side. So the goal was not to dig in the darker side, but to put light in the darker side.
Is there a subject which would you say, okay, this is still very dark for me, you know, this?
Probably plenty of them. So I try every 2 months to take a subject that is not as dark as it should for other people and to bring it in the light. But of course, I learn myself for every article. I learn a lot in order to prepare what I have to explain.
Is there a formula, or is there a sort of a piece of equipment which you say, okay, now I start to understand what electronics is about?
Probably the first time I met an oscilloscope was something that allowed me to understand plenty of things. Oscilloscope, yeah. Just looking at a signal, looking at a sine wave is a very impressive when you are young or when you are new in the technology, and understanding that if you put your finger on the probe, then you see something on the screen, and what is this signal? Where does it come from? That's very interesting.
Good.
So everybody has to buy an oscilloscope. So if you don't have an oscilloscope, buy one.
Okay.